And I'm live. That is pretty cool. Today is 4th of October 2025, Saturday. And yesterday was a contest, and my rank got increased a bit. And now, supposedly, I am a specialist in code forces, and that is kind of nice, like closer, getting a little bit closer to the goal. The goal of getting to a rating of 2000. And yesterday's contest, ooh, like, yes, even though the rank did increase, but I could have done better yesterday. Final standings, and let's also read the editorial for the questions. Yeah, I did three. Let's read the tutorial. The first one was, yeah, the first one was easy, but I took longer at this because I wanted to make sure that I'm getting this right. But yeah, in this we just have to find out how many different distinct numbers are there in the vector and multiply that by 2 and subtract 1. Like that is just how it works. That is what we had to do. And yeah, let's read the editorial for this one. Spoiler. Shit. That is a lot of things. Okay, let's just, yeah, let's just move on to CP31. I will be reading the editorial on my own. Yeah, not off stream. And for today, we have stop dance, round dance. This is the question. The starting question. Mux will server tmux set attach TCP CD 1600 in the next window also 1600. Run new update and sync. Okay, cool. And this is the question. Yeah, let's just get started. Round dance, 2 seconds, 256 megabytes. And yes, I also realized something after yesterday's contest that the number of questions that I'm doing is not going to be enough, since there are only 3 months left at max to get to a rating of 2000. That is 600 rating points. If I average 200 a month, only then I'll be able to get there. And yeah, this is hard. This is hard. The number of questions I have done is just this much, 332, and I think I would need at least about 1000 questions. And in 90 days, that is about 700 questions. So if I average, let's say 10 questions one day, every day, so that would be 900 questions. That is 1200 questions by the end of this year, and that should be enough. So yeah, just a little bit of thing I had to say. And with that, let's begin. Round dance. And people came to a festival and decided to dance a few rounds. And people, there are at least two people in the round dance, and each person has exactly two neighbors. There are at least two person, and each person has exactly two neighbors. If there are two people in the round dance, then they have the same neighbor as each other. Okay, both. If there are two people in the round dance, then they have the same neighbor on each side. Okay. You decide to find out exactly how many dances there were, but each participant of the holiday remembered exactly one neighbor. Your task is to determine what the minimum and maximum number of round dances could be. For example, if there were six people at the holiday and the number of neighbors they remembered are equal this. Okay, there were six people, and this person one number one remembers that they had person number two as their partner, person number one 4, 3, 6, 5. Okay, then the minimum number of round dances is 1. We can have one here, person 2, right, and person 3 has person 4 as their neighbor, and person 4 has person 3 as their neighbor, and 5 has 6, and 6 has 1. And the maximum, okay, and the maximum is 3. 1 in this case, when 1 and 2, 3, 4, 5, 6, 5, just 2 people. Okay, okay. The first line contains T test cases, the next line contains N, and then there are the numbers. Okay, escalator. And this makes sense in a graph sense. If we have something like this, that is too small. We have something like this, right? And we can label this 1, 2, 3. It would be much better with literal writing. 1, 2, 3, 4, 5, 6. And from this, we can see that we have 6 people, right? 1, 2, 3, 4, 5, 6. There are 6 people, and 1 has 2 as their partner, and 2 has 1 as their partner. So this same edge will work. Then 3 and 4 have each other as their partners, and 5 and 6 have each others as their partner. So in the case of minimum, right, we have to find the minimum number of group dances and the maximum number of group dances. In the case of minimum, this is not even a very good example, but anyways, in the case of maximum, we will see how many components there are, and we will make that one component, right? Here are 3 components, so the number of components would be the number of maximum possibilities, and minimum, I think we should be able to make to just we can just connect edges in these graphs like this. Yes, we should always be able to do this. And answer would be 1 for minimum always. Okay, it is 2 in this case. In the third last case, this one. Here we have 5 people. 1, 2, 3, 4, and 5. 1 has 3 as a partner. Let's make that with green. And 2 has 5 as a partner. 3 has 4 as a partner. And 1 and 4 has 1 as a partner. And 5 has 2 as a partner, which is like already there. Now this is like, yeah, cool, makes sense, makes sense. Here we have 2 components, right? One component is this one, and one component is this one. So maximum we can do is 2. That is just the number of components we have. But how many can we join with each other? How many how many components can we join? So here a node can have at least at max 2 degree, and this node only has 1 degree. This node also only has 1 degree, so they are free to be joined to anything else. But the thing is, in this other component of 1, 3, and 4, none of the nodes have a extra free degree where we can join. So the minimum is also going to be 1. Yeah. Good afternoon. Yo, hello. Thank you. I did really bad. Yesterday was bad. I think because there were not a lot of contests in the past 1 week. Yeah, this and this. Yeah, I feel like we have to do a lot of questions. A lot of questions. Yeah, the number of questions we are doing is not enough. Like, think about it. We want, like, me, you, and other people, we want to reach candidate master by the end of this year, and the amount of questions that we are not doing is not enough. It is like not even close to what we should be doing. I tried to solve both C and D, but was unable to come up with working solution. C was range. Yeah, C was about related to range, finding things in a range. It was giving one of, in some cases, of those special cases. Because of those special cases, the higher we, the harder it becomes to progress. Yeah, yes, it does. And hello. Yes, but that is what we decided, right? Yes. So yes, I have decided, like, on the stream, I will be solving CP31, but off the stream, I will be doing more questions. Yes. At least 10 questions every day. We can go to this problem set section, and let's say questions with a rating of 1500, apply, and just solve questions which I haven't done before. Yeah, just randomly solve questions, because the amount of questions we are doing currently is not enough. Like, literally, it is not even close. And getting back to this question, yeah, it is not enough. No, not even close. Yes. So yes, in this question, the answer for the maximum is going to be the number of components we have. And wait, is it ever the case when the answer is not possible? No, it is always sometimes possible. Yeah, so for maximum, the answer is number of components, and for minimum, we will see how how many components can we join. Here we have, in this particular component, we have 2 degrees free. So yes, we can join two different things, nodes here, but in this component, we do not have any degrees free. And to join all, yeah, this component, so we just have to figure out a data structure which will be efficient in finding out this thing. And in a component, we just need two things: the number of components, and second, the degree that a component has. If a component has degree 1, it is going to be on, like, at an edge place. But if a component has a degree 2 free, 2 degrees free, then it can be, like, joined here, and it can, on the other hand, be joined to another component. And yeah, that is nice. Okay, let's do this. C in N and vector in A N for int reference X in A, C in X. And now we have to find the number of components, first of all, and also the degrees, extra degrees in each component. How do you do that? And shit, we don't even, no, we don't need this. What we need is how are other things connected to each other. Okay, vector, vector, int, yeah, pair, and yes, because a node can only be connected to two different things. That is why this much. Two things, and a size n, let's say n plus 1, and a pair will have initial values -1, -1. For int I equals 1, I less than equal to n I plus plus C in AI dot first. That is like, what is AI connected to, the ith node connected to. F makes sense, and we will say AI dot first dot second equals I. That is, this AI dot first is connected to I. That is cool. That is cool. Like, yes, that does work. Here we have a connection between I, the node at location I, and AI dot first, and that is what we are doing. AI dot first is one node and I is the other node. Okay, and these two are connected to each other. Okay, and int mx equals 0 for int I equals 1, I less than equals n I plus plus. We will also have a visited thing. I'm not progressing at all in the last 4 to 5 rounds. Yes, so you are realizing this, that is good, and like, it must be hitting very hard. Yeah, that is just how it is, and work hard. Yep. Just do not give up. That is the main thing. Visited vector bool size n plus 1, and if not visited I, then visited I equals true, and DFS all DFS on I dot also given a void DFS doesn't do anything, and takes in int I and takes in vector pair and a reference, let's say a, and there are like two things that this is connected to. First is the first thing in the pair, and the second is the second thing in the pair. So there is always going to be the first thing. If shit, we also need visited outside of this thing. So let's make it a bit set. Const int range is 2e5. 2e5 plus 1. Bit set of size range called visited, and not here anymore. Yep. And if not visited auto, let's say x comma y equals a bracket I, the things that I is connected to. If x is not visited, then visited x equals true, and DFS with x and a. Now, if y is not equal to -1, then check and not visited y, then visited y equals visited y equals true, and call the DFS on y comma mx plus plus. At least we have the maximum count correct. Answer is going to be wrong because we do not have the minimum. Wait, maximum is also not correct. How can it even be? Okay, because there are multiple test cases. So yeah, visited is like already initialized to something that is not good. Are you learning DS and Algo on the go from editorials? Kind of, but not exactly. Whenever I see that the like materials which I have are not enough, we just go outside and read further things. We have books, CP31, Competitive Programmers Handbook, and CLRS. This one, yeah, we have different material for different things. Bro, did you saw one chicken solution for B? We overcomplicated. We didn't. No, I didn't saw that. I was looking at like the solution by Jiang Li, and I was unable to understand what he is doing. And B was pretty good. Catching the king. Yes. Shit. Yeah, this was good. We had to see uh since D is going to go in one K, the best strategy for K is to go in the opposite corner against the D, and yeah, then just have to find the smallest number of steps that D can take to go to a corner, to that corner, and yeah, this took longer than it should have. Burnt chicken's solution. Let's see. Wait, he is not in the top 10. Mhm. Final standings, but he is, I guess, in the top 5 in the contest. Burnt chicken. Okay, yes, Code Forces does this. This is like not very good. It is still loading. Yeah, burnt chicken third. That is nice. He solved 9 questions. Shit, he even gave wrong submissions. Second one, that is a lot of boilerplate. Okay, he takes in all the values. Okay, and then rest equals 0. If R1 smaller than R2, then CH max, what is CH max? CH max is something res or R2, res, which is 0 initially, or R2 if R1 is smaller. That is the queen thing is on the right, and this is on the left. Then take the maximum of these, change res to the maximum of res or R2. So res would become R2, I guess. But if that is not the case, or else if R2 is greater, then we go to the right, ch max R2. Okay, this makes sense because we will go to the left, right? We will go to the left in this case. Checking maximum. Hello, congrats on becoming a specialist. Following you for 2 to 3 months. Any tips? Thank you for the congrats. And yes, just keep solving questions. And in yesterday's contest, I realized that we are not doing enough questions. So one tip would be to do more questions. Yeah, just do more questions and questions that are difficult, a bit higher than your current rating, like 1600 maybe. Yeah. So change maximum, and this does make sense. Shit. This does make sense if C1, if C2 is greater than C2. Yeah, change to rest or C2. Or if C1 is greater, we will go to the opposite end, which is n minus C2. And then print res. Shit. That is that is making sense, but like not at completely conscious level. At a like peripheral level, this is making sense, right? A little similar way, like one thing, how much he can go in opposite direction plus the difference between both of them, but can calculate both in a step. He is just moving during itself to the corner. Yes, he's just moving to one of the corners. And the thing is, yesterday, let me show you. I thought that if he is, let's say, in this place and he needs to go here, right? So he needs to go this much distance, this much, and also this much. And here we can see that this distance, this one is greater than this. So, and also this guy can make diagonal moves in which he is reducing this distance and this one at the same time. So, since this is greater, we will only have to move this much distance to get from here to here. Because let's say, since this is greater, this horizontal distance is greater, let's say he keeps moving to some point till this distance and this are same, and then he starts moving diagonally, because here we will have this much and this same, and this is a square, and yeah, he can just go directly to the corner, and the total distance that he moved is this plus this, because each diagonal is also considered as a single move. Shit. Changes not be saved. Okay, so yeah, in total he just moves the maximum distance. That is what he is taking, the maximum distance. But there is this balance, right? F2 difficulty, it feels like stuck. You need to iterate faster, right? I mean, if you are solving two difficult questions, so it might be because your basic concepts are not clear, maybe, or maybe it is just you are not at that level currently, and you can solve a bit easier questions. First, I was calculating for only one way, either row or column. Then I take max of both. That is also something you can do. Calculate only for row. And if if they are in the same row or the same column, then the distance is just this much. And shit, yeah. And this is just a geometry question, and we would have to read more on geometry, right? CP handbook. I think there is a section on geometry in this book. Yep. And there complex numbers, points and lines, polygon area, distance functions. This Manhattan distance, rotating coordinates. Yeah. We have to read a lot. We have to read a lot to get up to candidate master. So editorials is the way. Then I am just curious. The thing is that the goal needed to reach must be minimized with loss and maximize reward. But I don't know how CP fares. Minimize with loss and maximize with reward. Okay, if that, I mean, how can you do that? How can you minimize the loss and maximize the reward? Relatively speaking, if your loss, what you are risking is minimal, your reward will also be minimal, and what you are risking is high, then your reward will also be high. That is the sour truth. And yeah, yeah, so you cannot do this. This is like, no, you cannot do this. It's not how the world works. Strategy. I saw this one. Demon Slayer movie. Okay, Pro is into Demon Slayer. I am amazing. How are you? And yes, let's get back to this question. Start. Okay, yes. No more reapping. The minimum number of the number of components there are, and also depending on the degrees of the components. Okay, how can we calculate the degrees of the components? We can know the edges which are in a component. Yeah, we can know the edges which are in a component, right? And we can know the nodes which are in a component, and we can just see how many things they are connected to. And we can do this here or inside our DFS function. But before that, we have to fix this part. I think we should create a bit set and then send it. Not a bit set, but yeah. But bool reference visited, and we will create bool visited size is n plus 1, and initially everything is off, right? So now we will get, okay, okay, we have to send n visited. Okay, internally there also, yeah. Shit, this is y. Okay, and we do have, yes, these are correct, except this one, y. Okay, there is something wrong with this one. Everything else is correct. And the fourth last, 1, 2, 3, 4, this one. Okay, there is only a single component in this. There are in total 6 things. 1, 2, 3, 4, 5, 6. 1 is connected to 5. 1 connected to 5, and 2 connected to 3, and 3 connected to 4. 1 connected to 4. 5 connected to 1, which is like already there, and 6 connected to 2. So there is only a single component. This whole thing is connected. Okay, this whole thing is connected, and the algorithm broke because 1 and 5 have each other there. Okay, yeah, I guess pair representation is not that good. Let's just use a vector in that case. And CV. ENC and AI dot pushback. AI is connected to C, and also a C dot pushback I. C is connected to I, and change the function definition in here for int x in A, A connected to everything that is connected to I, and if not visited x, then visited x equals true, and call DFS on x with A, and also passing the visited vector. Okay, that is pretty correct. Vector in. How about now? We do have these things correct. Yeah, these are correct. We just have to uh, find these minimum values, and this would depend on the degrees of these components, spare degrees in these components. Yo, Demon Slayer, yo. Wait, B was about 1000, and if it was about 1000, we should, I guess, feel bad because it took us quite long to solve B, and to solve C. C was not even, yeah, C was not that some unique hypothesis is being used in C, but I guess there is a stress which is involved when we are solving questions during a contest, which is just not there otherwise. And we just have to get used to that stress and be able to solve the questions in that stress. And yesterday, tomorrow is also going to be a contest, and that will be at will start at 10 in the night, and that is like too late. Okay, after finding the components, we need to figure out the spare degrees in a component. And how do we do that? We can create, we can have our DFS have a vector which, okay, how do we do that? We need to know how many things are set as visited, and then see their degree, right? And then see their degree. Hmm. Yes, we have to see the degrees. Each component, how many free degrees are there in the component. We can pass into our dfs function extra vector, which will keep adding these x if they are like a part of this current component. And when we have that, we can have here a loop which will go through all of those nodes in this thing which is returned or changed by our dfs function, and we will count their degrees. And at maximum, we can hope to find out a degree, spare degree of 2, and at minimum a spare degree of 0. Let's have that. Vector int or node, pass in nodes, and whenever we see this thing is not visited, we'll do nodes dot push back x, which is just kind of like keeping track of which things have been turned on as visited in this current pass of DFS. End nodes and nodes dot push back. Okay, this will be fine. This will be fine. I think, yeah. Nodes dot push back I, and then end sphere equals 0, and for, or yes, shit, instead of this we can have a queue with queue, or a stack will be much nice. Stack of integers implemented using a vector of integers. We'll call it st, and stack dot push back this thing, because it is like much simpler to put onto a stack and remove. Like stack of integers reference st, not push back, but instead push stack, and here we'll also send in st, that is nice, and while not st dot empty, while there are elements in st, we will get the top node index equals st dot top, and pop st dot pop it off, and now we have to see the degree of x, and if it is 1, add that to the sphere, and if it is 0, then yeah, nothing. So size, it will depend on size. If x dot, or if a bracket x dot size equals greater than equal to 3, or greater than equal to 2, then nothing. Continue. Wait, on 2 we cannot see for sure, but at 2 we can see something. If a x dot size equals 1, then sphere plus plus, and else if a x dot else, the size will like only be equal to 1, only be equal to 2, and when the size is 2, what we need to see is if okay, we can add that condition right here, this, or ax dot size, yeah, it will be equal to 2, if when the size is, if this thing is false, only then this other statement will be evaluated, and this would just mean that the size is not 1, and we already know that the size is not 2, the size is not greater than 2, and size is also not 1, and we know that the size is not equal to 0, then the size must be equal to 2. At this point, we can then safely evaluate ax0 equals ax1. then spare plus plus. Now, when we have this, we can also have a new vector of int bool what spares dot push back spare if spare. If spare, no, just push it. Even if spare is 0, just push it. Now we need to see how many of these components we can put together. For all the components where the degree is 0, int mx equals 0, right? Not mx, mn equals 0. And mn will be at least equal to all the zeros in the spare vector, spare dot begin and spare dot end 0. Count the number of zeros in spare. Mn will be equal to at least that much. Yo, we go Vim. We use Vim. I think we overcomplicated, but rating might be only 10, 1000. Yes, we do overcomplicate during contests. Yeah, bro, I wanted to start competitive programming. Can give a brief roadmap. Yes, you need like at least two things: questions and theories. For questions, you can go to this thing, CP31, and start solving simpler questions and develop a mindset for solving problems. And for theory, you can go to CP handbook, and that is just all you need to begin solving, to begin getting into competitive programming. Points were same for BNC. That is crazy. That is crazy. Points were same for BNC. C was much more difficult than B. B was, yeah, B, the amount of time that we took on B was way more than what is justified. But C was, yes, C was kind of difficult. Yeah, yeah, but we gave too much time on B. Right here, count the number of zeros. That is the minimum value for the minimum. And now we will see how many components are left and how many ones we have and how many zeros we have. Ones equals count sphere dot begin sphere dot end, count the number of ones we have, and end twos equal twos. Yes, and look at this. Right now my cursor is here, right? And I will increase this one by 1 and this will become 2. I think B was more tough for me than C. Shit. B was more geometrical. I guess this depends on the mindset of like how your particular mind is trained for, what kind of things are easier for you to think about. And for me, B was more geometrical and more easier for me to think about than compared to C. But C was also kind of geometrical. Yeah, it just depends on what you think about and how your mind is. Think it hard, but after seeing Burn's chain solution, I think it was very easy. Yes, but that is the thing, right? After seeing the solution to questions, we think, okay, of course, it is easier. But to create those questions, to get up to those solutions on our own, to mm, come up to these easy solutions on our own is very difficult. And yeah, I guess this is just something we will get after some time. And look at this cool trick. My cursor is here, and I will increase this one. Now it is 2. That is Vim. That is just amazing. I can also decrease this by 1, and look at this. I can keep decreasing it, or I can keep increasing it. That is crazy. And I can make this directly equal to 2. And that would be 19A2. That is Vim. That is amazing. Okay, and minimum. Minimum. Like, yes, our answer would at least be equal to the number of zeros because that many component we will have to have different. But for ones and twos, we might be able to spare uh, connect these components. And what does this ones and twos even mean? Ones means the ones is the amount of components which look like this, which can be connected to something on one end, and twos is the amount of components which kind of look like this. And yes, I am depicting a component with a single node, and that, like, that works, that is fine. So how many components can we create at maximum? So these ones can only be at ends, right? And the best we can have is number of ones divided by 2. That is, yeah, we cannot have lower ones than this. Let's say we have 4 ones and no twos. If we have 4 ones, we have 4 nodes which look like this. And we can say that we connect these two together and these two together, and that is cool. But if we had any number of twos, we can always put a 2 in between like this. If we have at least like some number of ones. But if we do not have any number of ones, then we will have to connect these twos among themselves, like kind of like this or anything. So yeah, and what if we have a odd number of ones? Something like, let's say 3 ones. This one is just dangling, so we will have, and this is 3 components, so we will have to take upper bound of ones. So mn plus equals ones plus 1 divided by 2, and if there are ones, then we can always fix our twos, but if not ones, then we will have to add mn plus equals bool twos. Like if there is at least one twos, then add one, but if the number of twos is 0, then do not add anything. And then we will output, let's see, nodes is nothing, and that makes sense. I think we, yeah, scan. Okay, ST, line 35 is 35. DFS, ST, what is wrong with ST? Okay, because of this, I think that should not have a spare dot begin, spare dot end. Spares makes sense. Substitute spare with spares. Only. Alright, cool. That does work. That does work, and I think it will like always work. This does seem correct, and we can submit this. Hello. 42 minutes. 42 minutes is a lot. Shit, yes, 42 minutes is a lot. Okay, this might be correct. Okay, that is correct. Cool. 43 minutes, let's say. 43 minutes. And I think the mindset with which we approach a question has to be different. When we read a question, we have to have a mindset of attacking that. Now, since I'm reading this question, I have to do everything and put forward everything that I know to solve this current question and forget about everything else. That is, I think, what is called focus. That is also done. That is nice. Shit. This, okay, this will take getting used to, but yes, I might also lose this because I only have 14, 17 as the rating, and yeah, I might just lose like 100 points of rating in the next contest and maybe like 300 rating points and become a newbie. That would be nice. Okay, let's read the editorial. And before reading the editorial, let me guess the tags for this question. And I think in the tags, there we will see graphs and DFS. Yeah, graphs and DFS because, yeah, it was not graphs, DFS. What is DSU? Disjoint set unions. Okay, disjoint set unions. Taking unions of sets which are disjoint and get help with your toughest homeworks. Yes, right. We do not have homeworks. Let's read the editorial. E. Mr. Mike. Let's build an undirected graph. Yes. Where I to AI. Yes. Let's split the graph into connectivity components. Denote their numbers by k. There could be not more than k round dances. Yes. Since the degree of each vertex is not more than 2, then the connectivity components are simple cycles and bamboos. Okay, I don't know if that is a technical term. Simple cycles, I think, is a technical term, but I cannot be very sure about bamboos. If we connect the vertices of degrees 1 in each bamboo, I think that might actually be a technical term, bamboo. We get a partition into k round dances. Okay, now let's try to get the minimum number of round dances. Nothing can be done with cycles, and all bamboos can be converted into one. If you get B bamboos and C cycles, what do bamboo is an actual technical term, I guess, and C cycles, then the answer is C plus B to C plus minimum of 1 or B, where B is a bamboo. I think by bamboo, they mean the same thing that we were representing with twos, the number of components which have two spare degrees. They might mean just that by bamboo. Yes, shit, bro is a quick learner. Banana beam, that is a very unique name, I would say. Vector A and G neighbors D. Okay, let's actually read this. Bamboos and cycles. Bamboos in graphs. Interesting fact. Bamboo tree. Ah, okay, something like this is called a bamboo tree. Okay. So yeah, this has one spare degree here and one spare degree here. So yes, the same thing that we were representing with twos. Now we can have a more technical name, which is bamboo trees. And this was downvoted somehow. Star graph. This thing is called a star graph. Okay, and this is also a tree. This is a tree. This is a tree. Both of the yeah, bamboo tree and tree. Yes. literally says tree in the name. Okay. So what do we have? Int a, taken into a, and ai minus minus to make this zero indexed, and then I dot insert, they have set g n, and gai dot insert I. Okay, add this to both the, yeah, I is connected to AI. So yeah, add this. Say I is connected to AI and AI is connected to I. Okay, and then D is the degree, and this does work because they are taking set, and if they are taking set, that is better than doing this thing. We could just use the size. That does make sense. That does make sense. Int bamboos equal to 0, cycles equal to 1. Cycles have degree 0, bamboos have, we, shit. We will not have anything with size 1s, with degree 1s. And that is true. Shit, we will never have anything with degree 1s. That is true. Let's substitute 2s with a technical term, bamboo. And will we still get the same answer? We are now just refactoring. Yes, we are getting the correct answer. And here also, let's spheres. That is a nice model, this one. But in here, we can use set in and set end. And here we can change this pushback with a insert. Wait, what happened? Yeah, insert. Okay, cool. And yes, if not visited, then okay, also create the stack. Yes, we do need the stack, then BFS spare while not empty, and everything else would change. This thing can be changed. Spare plus equals spare. Yes, we need to calculate spare. If the degree of the current thing is 1, spare plus equals 2 minus AI or AX dot psi. Set of integers AI. Yes, yes. Is the refactoring correct? Seems to be. Yes, it does seem to be correct. That is pretty nice. Yo, it was bad. Yesterday's contest was bad. Could have been much better than it was. Which I Vim. Hello, Explorer bro is exploring. Guys, how to start coding? Okay, if you want to start like literally even coding, then there is one of the best things you can do is CS50. Yeah, like yeah, this is the best thing you can do. Computer science. Yeah, this is a course. This is a free course by Harvard. And yeah, it is like all the lectures are free on YouTube. You can just take this course. First problem. Okay, let me see. Okay. Yeah, in the first problem, we just had to find out how many distinct integers there are. And we can see like It does not matter if I have one 5 times or just one time, because I need to make one, right? So let's say you have a single integer 1 which you need, and your initial array is 0, and you have two operations. You can increase all the numbers by some certain number x, or you can choose some numbers and make them equal to 0. So let's say you have to create 1, then you will just do one operation and convert this original array of 0 into a array of 1, and you have it. But let's say if you have two integers, 1 and 2, and initially your array is this, and you want to convert this 0 0 into 1 2, then what you will do, since here the difference is of 1, right? This is 1 and this is 1. So you want, when you are doing the increasing operation number 1, when you are increasing the elements by some number x, then you will be increasing this number by 1, right? And when you are increasing all the numbers by 1 for the last operation, first operation, then you want this number to be already greater than this number. And by how much amount greater? You want this number to be greater by 1. That is the difference between 2 and 1. And so what you will do, since you want this to be equal to 1 and this to be initially equal to 0, and you want something like this, and then you can do operation 1 and increase all the elements by 1. You will have 1 2, and to get here you need something like this, and to get here you need something like this, and to get here you can start from here. So at this start location, you do operation number 1, increase all the elements by 1, then make this number equal to 0. You are here. Then after that, you increase all the numbers by 2. And in total, you did one operation here, one operation here, and one operation here. So in my head, it was like, when you need when you have one distinct number, then the answer is 1. When you have two distinct numbers, then the answer is 3. When you have three distinct numbers, then the answer is 5. And it just keeps increasing by 2. And if you have n number of distinct numbers, answer would be n into 2 minus 1. But I was like very skeptical of this formula and I hesitated. And yeah, that's why it took longer than it should have. And what books have you been reading to, CP? Just the handbook and CLRS, and how helpful they are, as much helpful as you want them to be. If you are like, I would say the contents in this handbook are enough to get you to candidate master if you were to read this properly and understand everything that is in this book. This can take you up to candidate master. This one is more research friendly, more theoretical, and this one is more practical. This is more tuned for competitive programming, and this one is more tuned for a course. And yeah, it depends on what you want more. For me, I want to get better at competitive programming, so I read this. And when something is like not enough, like dynamic programming content in this book is not a lot, I went to CLRS and read about dynamic programming from CLRS. I'm currently 1200. How can I reach 1400? Solve more questions, practice, that is the thing, because that will, and also look at what are the mistakes that you are making and give yourself constructive feedback. That would be nice, very nice. And wait, yes, yeah, bamboo. Bamboo is a new technical term that we have discovered for a tree that looks like a single line. This, something like this. This is a bamboo. Bamboo. Yeah. Okay, now we can move on to the next question, I guess. We have done one question, and that is nice. To become max. It's different. That is like a Tame Impala song. And what is this? What is this shit? 1 square, 2 square, 2 square, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we have squares due to some reason that it's different. Okay, let's start solving this question now. So do you do this thing where you write takeaways of each problems and you have solved in an Excel sheet? No, that would be kind of too much. Two red coders recommend this. No, I do not take things on Excel sheet. I mean, if they are telling you you want, you can do that. If you want to take things on Excel sheet, for me, it is more like I do not want to create notes. A better thing than creating notes is like take pen paper, write something down which I'm thinking about, and then maybe throw the paper. It does not matter. The main thing is that I do understand and I do not have to preserve what I wrote down. The more important thing is, was I able to express the thing completely or not? Let's do this question now. Cool. In a carnival game, there is a huge pyramid of cans with 2023 rows, 2023 rows numbered in a regular pattern like this. Okay, you throw a ball at the pyramid and it hits a single can with the number n square. This causes all cans that are stacked on top of this, all of this can fall. That is, n square can fall, n square falls, then the cans directly above n square fall, then the cans directly above those fall. For example, the picture shown above, we hit 9 and all of these fall. What is the sum of the number and all the cans? Recall that n square equal to n into n. Ah, that is cool. Okay, so for 9, answer would be 9 square plus 9 square 81 plus 5 square 25, that is 106 plus 36 142, yes, 142 plus 9 151 plus 5 156 156, that is correct. Okay. Okay, so we just have to see what things are above a given can. So there must be a pattern. 1, 2, 3, 4, 5, 6, right? That is how it is. Yes. 7, 8, 9, 10. Given a child, can I know the parent? The left parent and the right parent. One has two childs, 2 and 3. 2 also has two childs, 3 and 4, 4 and 5. Then 3 has children, 5 and 6. Does that help? First child is this into 2 and this into 2 plus 1. Here also first child is this into 2 and this into 2 plus 1. But here the second child is the node multiplied by 2. But this other child is divided by 1. Can we know at least the row in which this thing is and what is the maximum value of n? Shit. Okay, we can iterate through n. That is fine. Can iterate. Answer is going to be massive for some values. We just need to find a pattern here. Given a thing, how can we figure out its parents? And for them, how can we figure out their parents? Or just at least find out the first pyramid where we cover the whole row, and above that we just find the sum of everything, of all the numbers there. Colin Callan, yeah, he's a nice guy with very long hairs. And Vivek Gupta. Placement? Uh, I don't cannot say for sure, but yeah, hopefully. Okay, so we need to find a parent. Let's increase the graph. 1, 2, 3, 4, 5, 6, 7, 8. This is Pascal's, no, this is not Pascal's triangle. 11, 12, 13, 14, 15. We have to see a pattern here. 12 has two parents, 7 and 8. We can suppose everything else is just 0, 0. So 11 has two parents, 0 and 7. In one row, we have one number. In the next row, we have two numbers. In the next row, we have three numbers. In the next, 4 and then 5. Okay. So given a number, we will be able to figure out in which row it is, right? We can have a integer, let's say I equals to 1, and a summation sm initially equal to 0, and we can have while this number, it's which is n, while n, no, is, no, yes, while n is bigger than sm, we will do I plus sm plus equals I, we will add I to sm, so sm initially equals 0 and n is like always equal to 9, then sm will become 1, and we will increase I will become 2, sm, and this is still smaller than 9, I is 2, and we will add I to sm again, sm becomes 3, and this is just how many numbers are there till the ith row, right? Ith row, how many numbers are there till the ith row? When I equals to, there are 3 numbers, right? Yes. And then I also increases by 1, and I becomes 3, and 3 is still smaller than 9. We make this 3 plus 3, sm becomes 6, and yes, after increasing sm, I also increases, and I becomes 4, sm is 6, and 6 is still smaller than 9, so we go inside the loop again, and we increase sm by 4, sm becomes 10, and I becomes 5, and now sm is greater than, yeah, than n, and I equals 5, and I is pointing to the next row, that this is n, and if n was equal to like 10, which is exactly the current value of sm, then also we will break, and I is always pointing to the next row. So our the row in which n is, the row, that row is I minus 1. But that, does that even help in any way? I don't think there is a nice formula. What we can do, is, we know this row is the fourth row, and our range of numbers which we have to add from this is, our range is 1, which begins from here. This is our starting point, and our range from this starting point only goes right once, and so yeah, which just ends here. Then in the above row, our starting point will decrease by 1. So initially we were skipping 2 elements, now we will be skipping 1 element, and our range will also increase by 1. So our range will be this much. So we will add square of this plus square of this. Then our initial point will also decrease by 1. And here on this row, we will leaving 1 element out. Then we will be leaving 0 elements out. So our left range is like everything here is 0. And our right, the whole range is just every number here. I think that is good. That is something we can do. Okay, so first just figure out where the row is and keep decreasing the starting point and keep increasing the range by 1, and at some point everything would be like, yeah, in the range, and at that point we can just look at what the last element is, and we can also have a prefix which we can use to quickly figure out the sum of everything till the nth number. And there is like a formula for this. For 1 square plus 2 square plus 3 square plus dot 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 till n square, the formula is n into n plus 1 into 2n plus 3 divided by 6. We can use this to figure this much out quickly when we know every row above this and this included. We have to have the sum of all of these numbers. So that is nice. Okay, we got this. Got this. We can do this. This is nice. Maybe BFS. I don't know. This doesn't seem like a graph question. Meetup. Yo, gotcha. Yeah, this is not a regular tree. This is like kind of different. Long, long. N, even though N doesn't have to be long, long, still, let's say long, long N. And yes, that is all we have. And now we need to figure out the row. Int I equals 1. I is always pointing to the right thing, and long, long Sm equals 0. While n greater than Sm plus equals, and I plus plus. And after this, I minus minus. We know the current row, and yes, and there are I number of things in the ith row. 4, 5, 6, 7, 8, 9, 10. There are in the ith row, this is fourth row, 4 things. We need to, like, our range will start from 1, but we need to figure out the starting point, which depends on n. And how do we find out the starting point? That is easy. We can take the last row and subtract the last number from the last row from n, and we will get, in this case, 9 minus 6, we will get 3. So our range starts from the third element. This is 1, 2, and 3, third element, this one. And but how do we figure out what is the last number in this row? We do I minus 1, we get 3. And that is just the third triangular number. Yeah, so we do I minus 1 into I divided by 2, we will get 6. I is 4, so 4 minus 1, 3 into 4 by 2, we do get 6. Subtract this from n, And shit, we do not want to store this whole tree as a data structure. So shit, that would be bad. So when we are traversing through this whatever tree structure, we will be creating elements on the fly like this. Okay, so we know our starting point and we know our range. Range is initially equal to 1. So in r equals 1, range is 1, and in s will be equal to n minus I minus 1 into I whole thing divided by 2 and minus 1 to make this 0 indexed. And okay, cool. R is our range, right? Yep. And we will keep doing this while I is greater than our range. That is, since we are currently at the ith row, and from this ith row, we need r number of elements. And while we are not taking all the elements from the current row, we will keep doing this. Answer equals 0. So from the starting point, we have to take r number of elements and take their squares and add them to each other. We have a s and we have a r, and we also have I. So using I, we can figure out the first element, which would be easy. And then we can just add S to that and go to the right R number of times. Okay. I is initially, in our example of 9, I is initially equal to 4. So to get the first element, we get the last element in the last row and add 1 to it. Okay, cool. Which is just this. Which is just this. And big, as in like begin, this, and add 1 to this. And also we cannot go past the right limit or go left. Yes, we cannot go past the right limit and go left to and go left beyond like the 0 element. So we will never decrease our s smaller than 0. And now range for it. I don't know. Let's say j equals 0 and j lower than r, j plus plus. Answer plus equals big. Okay, we didn't even use s. What is that? Add 1 and s plus. Answer plus equals beginning, square of beginning. And also there has to be one more condition, that we do not go past the last element in this current thing. And last is going to be I into I plus 1 by 2. So while j is smaller than r, and the current element would be beg plus j. So this thing, and beg plus j is smaller than last, smaller than or equal to last. Answer plus beg plus j into beg plus j. And cool. Now for the next thing we do r plus plus, increase our range by 1 and s equals minimum of 0 or s minus 1, or not minimum, maximum. Okay, cool. Uh, right, so that we do not go past 0. Okay, now there are some I layers remaining. In our example, our loop would exit when I equals 2. So we will just get this element, which is going to be I into I plus 1 by 2. That is 3 into I is 2. So 2 into 3 by 2, we get 3, 3. And after getting that, we will apply the formula n into n plus 1 into 2n plus 3 divided by 6, and that should work. Like that should just work. Okay, so int n. Now we need this last element in the ith row. Let's call it L, right? Okay, that is the original I in, let's bracket I into I plus 1 divided by 2 and answer plus equals. Okay, now let's also make this long because answer could be very big and it is just better to be safe. And now we have to apply this formula in white, where n is L into L plus 1 into 2 into L plus 3 whole thing divided by 6. Yeah, and should work, hopefully, or maybe not. Hmm, 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 hmm. Yes, we are going to the like left layer. Okay, it's okay. That is just a minuscule difference. 4 in this. We got 5 and 10 in the first one. We are getting 160. That is wrong. Okay, we have just one test case, and that is 9. Let's see. 81. 81 is correct, like absolutely correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for the first row, we got 81. That is absolutely correct. For the second row, we should get 25 plus 36, 61. We should get 81 plus 61, 142. 142, right? And then we exit. Hmm. Then we exit. And we should add to 142 1 square plus 2 square, 4 plus 9, that is 14, and the answer should have been 156, but that is clearly not what we output. So are we exiting with the correct value of I? I think we are exiting with the current value of I. In just one test case with 9. 2. Yes, 2 is correct. 2 is the correct value of I. And when we apply this formula to get L should be equal to 3. One test case, 9. L is equal to 3. So is this formula wrong? Let's apply 3 here. 3 into 3 plus 1, 4 into 2 into 3 plus 3, that would be 9. 6 plus 3, 9 divided by 6 to 18. Formula is wrong. The formula was in CP handbook in like the first chapter, mathematics section. This 2n plus 1, not 2n plus 3. Shit, I messed up. Shit. Okay. Hmm, okay. 50. 54, we get an answer of 50 for the value. Which one? 50 is, wait, no, 50 is never the answer. 46 is the correct answer. 46 is the fourth last. 1, 2, 3, 4, 6. Answer for 6 is 46. 1, 2, 3, 4, 5, 6. 6. So our starting point is 6 and our range is 1. Then our starting point is this, and then our starting point is this. And that is amazing. That is like, okay, shit, that is amazing. So we will not exit I. Okay, okay. We are prematurely exiting I, exiting here, while I lower than R. Yes, that is wrong. That is wrong. We will only exit when starting point is 0. Well, no. While S, yes, S is either S is keep going while S is 0, while S is like non-zero. And even if S is 0, see that go inside if R is go inside when I is greater than R, and only then exit. Okay, that is correct. That is correct. That is wrong. For 30, 30. It correct answer is 21. 21, which is fifth from top. For 4. For 4. Here our range will not increase. That is also correct. Yes, this is also something we have to keep in mind. Range cannot just blindly keep. Okay, instead of having a range, wait, no, I am not in IIT. God's child. Shit. Meetup. Okay, instead of having a numerical range which says from the starting point get this many elements to the right, let's have pointers. Just like we have a starting pointer, we will have a ending pointer, right? Yes. And the here in this case, ending pointer will be at the right, and a starting pointer will also be there. Ending pointer will increase by 1. Starting pointer will remain 0 because it cannot be negative. Okay. R int r initially just equals the starting pointer, and either s is non-zero or r I is greater than r minus 1. For example, if I in this case is equal to 3, here we have 3 elements. For I equals to 3 elements. We will only exit if s equals 0, right? And r equals 2. I minus 1, not r minus 1. I minus 1, and here we have r. R is 2, I is 3, I minus 1, 2. Yes, that is good. We have to change how we are iterating. J lower than equal to r, that is the only change. No. Yes. No, no, no. Okay, yes, this is wrong. Int j will start from s, and while j is lower than equal to r, j plus plus. Now, what is going to be the starting point? Let's call this buff, as in like the buffer. We don't need last anymore. And what we'll do is buff plus j. J is the index and buff is the buffer from the start, which is the number of elements, the last element in the last row plus 1 to get the first element in this current row. Okay, that is our buffer, and from the buffer we are going j points to the right. If j is 0, we are at the starting element, and if j is greater than 0, then we are off to the right. Okay, cool. And r cannot just blindly keep increasing. R equals minimum I minus 1 or R plus 1. But that is for the next phase. Yes, in the current row, there are only I minus 1 indices, but in the next row, there are going to be one less. So I minus 1, I minus 2. And the phone is going to die. We can do this, and yeah, that also works. And I think now we are happy. Okay, this is still not working. Something wrong with this. We are getting a wrong answer on for 21. Again, 21 is fifth from the start, which is 4. We are saying 30. Answer is 30. Shit. That does make sense. We cannot just I'm not doing anything for a living. I'm just a student in third year, and I live in Uttar Pradesh. Yep, UP. This makes sense. This is the correct way for reducing this, but let's say this is our right limit. Our right limit does not change in the next iteration, it just remains put. Okay, now that is a lot of numbers. Buff J, okay, is okay. That should fix. Cool. We can submit this, but is this going to be correct? Okay, let's delete the whole code and write this again from scratch. Int n, we take in n. Now we need to figure out which row we start at and what is the starting index and the ending index. We have, if we remember correctly, sm is starting from 0 and I it starts from 1. Int I equals 0, and we have while sm or n is greater than sm, what we do is sm plus equals I and I plus plus, and then we do I minus minus, and now we know we are beginning from the ith row, and what is going to be our starting point and our like right limit, or we can write it more clearly as left and right limit. Our left limit is going to be L equals the number of characters or the last number in the last row, last number in the last row minus n minus 1. Last number in the last row would be I minus 1 into I whole thing divided by 2. That is the last number in the last row. And we subtract this from n, and then we do minus 1. That is our ending point, and our left point is also same when we start, and we will continue this while two things, while s, while l, that is the left point, while the left pointer is non-zero, or I minus 1 is greater than r. We will do this, and long answer equals 0, and now we need to have a buffer so that we can iterate with a j equals left limit, and while j lower than equal to the right limit, and j plus plus, and we will add to our answer some buffera, no, not buffera, buffer plus j, yes, buffer plus j into buffer plus j, and our buffer is going to be long because yes, we do not want any overflow. And what is going to be our buffer? Our buffer is going to be the first element in this current row, which is the last element in the last row plus 1. That is going to be 1 plus the last element in the last row, which is I minus 1 into I divided by 2. And that is nice. Now, answer plus equals, since there are some I, I minus minus, we also have to update the things I minus minus, and S equals maximum of 0 or s minus 1, s reduces by 1, r equals minimum of r or I minus 1. Yes, yes. And now if there are some I values left, answer is going to be I into I plus 1 into 2 into I plus 1 whole divided by 6. See out answer. S makes sense. Fs And shit, that also makes sense. FS. Hmm. Hmm. Okay, things are messy. Answer initially is 0. Okay, shit. Okay, we have to replace all of these i's with some value x, which is the last element in this ith row. That is I into I plus 1 whole by 2. And here substitute I with x and global. Should have worked, but did not in this one particular case. Shit, that is crazy. What if I is 0? If I is 0, then we get 0 because we are multiplying by I. And if x is also 0, we get 0. Long, long. Okay. We can submit this, hopefully. Okay, only, okay, at just the 40-minute mark. Okay, let's see. X is int. Yes, that was the problem. That was the problem. X was int and int is very small. Accepted. Cool. 40-minute mark. Hits different. That was the question. Refresh. Okay. Shit. I This is like very unusual to see cyan instead of green. It's a very, very new thing. Okay, well, let me predict the tags. I think number theory, we will see number theory, and yeah, number theory, or maybe not. Yeah, math. We can say math is number theory. Let's see the tutorial. Refresh. Okay, what should gold rush? Who made the most money in the gold rush? It was the one who sold. It was the people who sold pigs. Yeah. Yeah, that is a reference to something I don't even know what. Okay, that is a B2 bomber. There are many solutions which involve going row by row and using some complicated math formulas. Shit, I think they are referring to this thing. Going row by row and using some complicated math formula. But here is a solution that requires no formula and is much quicker to code. The cans are hard to deal with, but if we replace them with different shape, a diamond, we get this form. That is true. One, one, two, three. Okay. Now the cans that fall just form a rectangle. Let's rotate the picture. Shit. Okay. Okay, let's not read any further and let's try to recreate or think about what they are saying. We have this. Can you successfully predict the size? Yes, we the difference is in this row, the difference is in the first step, the difference is of 2, then the difference is of 3, then the difference is of 4, then the difference is of 5. And yeah, we will just do the same thing on here. And if we just know the dimensions of this rectangle, we will be able to figure out the answer. And how do we know the dimensions of this rectangle? If we have just 9 here, the number of elements to the right of this thing, plus 1. Yeah, the number of elements to the right of this number plus 1. That will be easy to figure out. And here on the other side, the number of elements to the left plus 1. Okay, because this much is going that way and this much is going that way. Okay, so we can figure out the dimensions of this rectangle, and then if we know the dimension, this thing, height and the width, we will be able to figure out this. That is doable. Excellent. Yup. Which college? Just tier 3 local college near my house. Is this TLE site? Yes, this is the TLE site. Time limit exceeded. Or more like TLE eliminators. Shit. They have a special offer. Hurry up. It is going to go away. Special sale is ending soon. Shit. What will you do if you do not take part in the special sale? Why is this so expensive? 2,700. And why is this one like kind of cheap? Beginner, self-paced. Okay, this is what we have. Okay, let's try to implement this solution. We have done our own complicated mathematical formulas solution. Let's implement this one, and that would be nice. Delete the whole code. And yes, I'm telling you that this is very courageous. This is very courageous when you just delete the whole code. Yeah, you have to have faith that you can rewrite the code again. Okay, we have n. Now we need to know the last element and the first element in this ith row. For that, we need to know I, and I equals 1 and long sm equals 0, while n greater than sm plus equals I and I plus plus I minus 1. So we know the ith row. Now in last or int right equals I into I plus 1 divided by 2, and int L equals the last element in the last row plus 1. That would be the last row, I minus 1 into I divided by 2. Now height and width. Height, height, height. Height is this thing, right minus 1. Yep, R minus N plus 1, and int width equals N minus L plus 1. And yeah, long answer. Long answer equals to 0, and for int I equals 1, I lower than equal to H I plus plus. The first difference D begins with 3 and with 2. The difference begins with 2. And for int J equals 0, J lower than width and J plus plus. Answer plus equals D is 1 and int C equals 0. So D plus equals D. Increase by D and increase the distance by 1, and answer the current number is, make this a long, and the current number is C. Yes, I think it is just C. So C into C. Yeah, cool. This should work, or maybe not. 92 to something is wrong. Height should be 2 and width should be 3. And yes, that is true. And our outer loop goes from make this 2 and make this I. We are beginning from here and J increase this late. Okay, I was expecting correct answer this time, but unfortunately, no. So our current number begins with I. For I equal to 1, yes, we add to our answer 1 into 1. Cool. Then our C becomes equal to 3 and D becomes 3. Right. So in the next iteration, we do 3 into 3 and W is equal to 3. So we will go through this 3 times. And this is our second time when C equals 3. So 3 plus 3, 9. 9 added to the original answer 1. Cool. Then C becomes D plus 3, 6 and D becomes equal to 4. Then we do our iteration again. We go through this and we do 4 plus 4 into 4, 16, 16 plus 10, 26. And we will just exit out of this loop. So it does not matter what happens to C and D. First row is amazing. Then I becomes equal to 2. Okay, and when I is 2, we do 2 into 2. This should be correct. Oh, here the difference was 2, then 3, then 4, then 5. Here the difference is 3 initially, then 4. Here the difference is 4 initially. Here the difference is 5 initially. Okay, so difference is also changing. That's I or more like I plus 1. Okay, that was not expected. 21 and 14. So we are still messing up. For the fifth case, we are messing up in the fifth case when 4, when n equals 4, we are messing up there. Yes, it is new Vim. Vim is good, bro. Yes, it is like Vim is good for everyone. Anyone's Vim is good. Look at this. For 4, 1, 2, 3, 4. And we will take the sum of these things. Width is 1. We add square of 1, square of 2, square of 4. One, yes, that is amazing drawing. 2, 4. And if we rotate, then we have something like this. 1, 2, 4. And here we should have 3, 5, 8, right? And our height here is 3, 3, 4, 5, 5, 6. Height is 3, which is correct, and width is 1. Height is 3, width is 1. height is 3. So we will go 3 times and C, and okay, so C is 1 when we add to the answer 1 square, and C becomes equal to 2 when we add to the answer C square, and C becomes equal to 3. Makes sense. I has to change. 1, 2, yeah, okay, so okay, I plus 2, and starting point is 1 plus I. Hmm? No, 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 no. It is difference is 1, then difference is 2, then the difference is 3. So I into 2 plus 1. No, I into 2. Let's say this is our series 1, 2, 4, 7 plus 4, 11 plus 5, 16. This is our series, and I equals 1 is this, I equals 0 is this. For 1, we have this. For the second place, we have this. For the third place, we have this. For the fourth place, we have this. And for the fifth place, we have this. How do we figure things out? So I guess uh, I into some number x plus 1, that something like that. And let's say I begins from 0, 1. So 1 is this, 2 is this, 3 is this. Initially, the last value. Yeah, okay. Let's say beginning equals 0, and I less than equal to h, and C is beginning plus I, and beginning equals the new beginning as beginning plus I, right? So that initially beginning is 0. Then we add 1 to it and beginning becomes 1. Then so I should begin with 0 and beginning should begin with 1. Okay, so I is 0, beginning is already 1. So in the first iteration, beginning is 1. When we get into the second iteration, beginning becomes 2. And yes, because I is 1, beginning is 1, C becomes equal to 2, beginning also becomes equal to 2. And yeah, we just keep moving forward from them. From that point, in the next iteration, I becomes 2 and beginning is already 2. So beginning becomes equal to 4. And then we add 3 to 4. Cool. So this should work, and yes, it does work. Okay. Let's submit this solution also, and let's see how this goes. This is Tokyo Night. Amazing color scheme. Color scheme, Tokyo Night. Night version of Tokyo Night. It's been just 2 hours and we have done 2 questions. Let's do more questions. This is, oh shit. This might just stay in queue. The same thing happened day before yesterday. Shit, okay, it is not submitting. That is fine. We can start doing the next question. Shocking arrangement is the next question. And how is the rank? It is 19.6. That is nice. Okay, running. That is cool. Cool. Okay. We can start solving the next question now. But before that, let me go to the washroom and I will be right back in a minute. I'll be right back. Yo, I'm back and let's do more questions. And let's try to do at least 2 more questions. That would be nice. If you could do, we could do 2 more questions of this rating. Cool. Shocking arrangement. Let's go. You are given an array A to N consisting of integers. Okay, such that their sum is 0. You have to rearrange the elements of the array so that the following condition is satisfied. Max of L to R is lower than max of all the elements minus the minimum, where x denotes the absolute value of x. Okay, the sum in this range should be smaller than the maximum element in the whole array minus the minimum element in the whole array. More formally, determine if there exists a permutation. This for the array A, yeah, these are indices. The condition above is satisfied and find the correct corresponding array. Recall that the array, this is called permutation. Okay, n is 300,000 at maximum. I is this, in other words, this is this, and wait, but what are these limits L and R? Just L can be equal to R. Okay, so what are these limits L and R? In the first case, we have question as this: -5, -2, 3, 4. Okay, I don't even understand the question correctly. That is a little too much stuff. Browser storage quota is not increased anymore. That is nice. Okay, we have this as the answer, and is our left and right like variable? Here the maximum minus the minimum. Maximum is +4 and minimum is -5. So if we do +4 -5, that is 9. And 9. And what we want is for left and right, maximum sum that we can achieve. Maximum sum that we can achieve is 3 plus 4, which is 7. And 7 is not greater than 9. That is very nice. So we just need to make sure that the running sum between any two indices L and R never exceeds 9. So we'll need okay, okay, okay. So first we will find out this sum, which is just the maximum number minus the minimum number. And all the numbers could be all the numbers are not positive because we have the sum of the total array is 0. So that is good. So all the numbers are not positive. We could have something like -1 plus 1 -1 plus 1. So the minimum difference that we can have is going to be 2. Yes, or 0. The minimum difference we can have is going to be 0 when all the elements in the array are 0, but that is like very trivial. We don't even need to look at anything. But the minimum difference we are going to have is 2. And what we need to make sure is keep this running sum smaller than the difference. Keep the running sum smaller than the difference. How do we achieve something like that? Here in this case, let's look at more examples. Here we have this, right? And our difference is 4 minus 3, which is 5. So we want our sum to be always smaller than 5. What we can do is plus, minus, plus, minus, plus. And that is good enough. And that does work. And we can see that our running sum is never greater than 5. Here running sum 0. When we get to here, running sum is -1. Or the minimum. Alright, we will have a running sum which S, which starts at 0, and a counter which starts from the first element. And we will add this, but we do not know which element to choose. I think we just take the biggest element, then the smallest element, then the biggest element, then the smallest element, biggest, smallest, biggest, smallest. And we just keep doing that while we are out. And yes, why are we doing that? Because we want our sum. At some point, our sum will have some minimum value. And let's say in our vector Smx is the minimum accumulative sum value. And like if we are forming a prefix sum of this, then Smx is going to be the minimum value of this sum, and the maximum value to the right of this minimum mn and s mx is going to be the maximum, and the biggest sum thus we can achieve in this is going to be maximum minus minimum. And what we want is to keep these things as close to each other as possible, as close to each other as possible, if that does make sense. So if we do take actually the maximum number a mx and then a m n, then in this range only we, what do we want? We want to be smaller than this. Okay, that is nice. That is nice. So if we have a maximum and then a minimum, our difference is a maximum minus a minimum. But here, when we are taking ranges, we are adding these a maximum plus a minimum. We are adding these things, s- and we are saying this thing is smaller than this thing because mn is negative. And then we choose a positive, the biggest positive number, second biggest positive number after mx. Positive or negative does not matter, it just has to be the biggest number. And let's look at the cumulative sum. Here the cumulative sum was mx, a mx. Then after this cumulative sum became a mx plus a mn, and that is like smaller than this number. This is smaller than this number, right? So if we create a graph, we have this at like highest here, and then this is decreased by a m n amount, and then we have the biggest positive number. I mean, so this becomes higher but not as high as this. Then we have a smaller negative number, and then we have the biggest positive, negative, biggest positive, negative, and no, at the end this is going to go to 0. Yeah, so that is fine. Our goal, yeah, that is fine. That is fine. That is like actually good. We do not have any answer in this. Okay. 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 Yes. This is cool. This is cool. We can have, so now we are going to have a couple of things. First is going to be our cumulative sum C, and we will use a multimap to store all the elements from this. and we will keep removing values from the multimap. Keep, oh no, we can just take a array, sort the array, have two pointers, like, and we will keep moving like this. Okay, that is nice, and we will add to C, and what we need to make sure is the minimum possible value to the left of C and the current value of the C, and subtract these two. Okay, cool, cool. This is doable. This is very, very, very much doable. Okay, cool. Int n, C in n, vector of integers a size n for int reference x, x in a. What we do is take in x and then sort a dot begin and a dot end, and now int l equals 0 and r equals n minus 1, the pointers, and long c as like cumulative equals 0, and we will also have long d. The distance is going to be the biggest element minus the smallest element, and the biggest element is on the right, so a bracket n minus 1 minus a bracket 0, and this is wrong because a n minus 1 is integer, a0 is integer, and a0 is very small integer, small negative integer, and a n minus 1 is a very big positive integer, so this might overflow. So this is wrong, but now good, because this is at least like long. So everything is long, and that is not overflow. And what we'll do is, while our range is L and R included, so while L lower than equal to R. Yeah. So in one step, we will move left to the right by 1 and R to the left by 1. No. Bool chance equals true, or is L equals true. Now, if is L, wait, shit, initially it is false because we are initially taking the maximum number. Yeah. So if is L, we take the left, but initially, no. Initially, answer is not L, and we will also have a vector int response size is going to be n for it, and int I equals 0. Yep. Res I equals L. Res I equals the number on the right, which is AR. Yes, we need to return a permutation. Okay, I thought, why am I sorting? Okay. And also, int MNC is 0. Okay. And after this, we will update C to be equal to C plus equals AR. And in this case, also R plus plus, or R more like minus minus. And in this case, if left, then Ri equals AL and C plus equals AL plus plus. L is moving to the right, and also I is always also moving to the right, plus plus. And if the current value of C minus the minimum value of C, which itself should also be a long, if this thing ever, if this thing ever gets smaller Yeah, if this thing, this is the sum that we will be able to achieve, the maximum sum that we will be able to achieve. Ever, if this thing ever becomes equal to or greater than or equal to D, then yeah, then we are like messed up. This cannot happen. Then equals initially, let's say, or not done, but bool possible initially, let's say true. If this thing is true, then we will say it is not possible. Possible is false and D. And update our minimum C to be equal to minimum C or MNC. And now if possible, we out yes with a new line, and for int I equals 0, I less than, or for int reference or int x in res, for int I equals 0, I less than n I plus plus, see out res I and space or a new line depending on I equals n minus 1. Else, if not possible, then we bail out. And okay, I do not just want to submit just yet. Let's see. I think this is okay. Is L equals not is L. We have to update that. And what else do we have to update? We are updating I, we are updating L. MNC is also being updated. C is also being updated in both the cases. And is L is also being updated. P is also being updated. And this should work. Hopefully. Maybe not. First of all, this is small case. Okay. And this is also good. This does work. This is fine. Here, this is also good. Here we say no, even though the answer is yes. Ah, that is correct. Okay, the strategy is wrong. Yes, strategy is wrong. And when it is correct, it is correct. But yeah, it is wrong at places. So yeah, that is messed up. Output two new lines. Not in this case. Okay, okay, the strategy is wrong. Bro, don't yes, he did become LGM. That is like amazing. Bro, did you learned binary search on answer? Wait, what do you mean binary search on which answer? Yes, in yesterday's contest. Yesterday was not a very good. The questions were very good. The questions were good, but yeah, the performance was not good. The concept is called binary search or ENS. On ENS, okay, that is a concept. Which concept? Like in reference to what? Yes, dominator did become LGM and binary search on ANS. Maybe I'm not getting this. Binary search on answer. Yeah, we can apply do binary search with things. That is very normal. Extension of binary search, for example, in Coco eats banana type of question, I think. Yes, we can apply binary search. Okay, yes, okay, no, okay, shit, okay, I do get. What do you mean by binary search on answer? And that is like amazing. We can do a lot of things with binary search on answer. Shocking arrangement. Okay, so we cannot do this. We want our C to be big. You know, shit, we can just keep making it as big as possible. Put up all. No, we do not want it to be as big as possible. No. Okay, this thing we have to change. Right. If L plus C, if L plus C, if using the number, big number from the left, minus MNC. This is the sum that we would get if we choose this current number, big number. If this sum is smaller than D, then we go with a number from the left. Right. Rest I plus plus equals AL and C plus equals AL and plus plus. But if we cannot, then we choose a number from the right. AR and C plus equals AR minus minus. Okay. I think we should. Boom. That makes sense. Okay. Yes, and this is like literally the correct answer. Left is small. Left is small. Left is small. Left is small. We do right instead of left. Yes. R minus minus. But if we cannot take a big number, we take a small number. L plus plus. Okay. This does work. This also works. No. Okay, this also works. And this works. Here we said no, that is shit. That is wrong. Four, right? Four. That is wrong. We will have a lot of ones. Okay, what are we seeing? R is pointing to the biggest element right now, and L is pointing to the smallest element right now. I thought tourist will get rank 1, like for the first 45 minutes. Tourist was first to solve questions till D, I guess. Yeah, I think he solved for the first questions. He was better than yeah, better than everyone, better than us. I would say better than Jiangli, better than Dominator. Yeah, and he's pretty cool. So here we have our MNC equal to 0, and we are checking if we do take the biggest number, what do we risk? We do not want the sum to be greater than or equal to D. Mhm. Oh, okay, this is correct. This is like absolutely correct. This is also correct. This is, wait, we don't even have to look at this. We can just look at the code. So by choosing the biggest number, adding it to the cumulative sum and subtracting the minimum value, is it still greater than smaller than D? Then if it is, then go with it. Choose the right number. Otherwise, choose the smallest number and reduce the current sum so that you are not increasing it a bit too much. Okay, okay, okay. This does seem cool. This does seem cool, and it would be very good if you could just get it right now. 30 minutes, 30 minutes. Okay, okay. Test one. I'm afraid. Shh. Okay, maybe we don't have to be afraid. Ah, cool. Okay, 30 minutes. That is the best time that we have ever taken to solve a 1600 rated question. That is good. 30 minutes, and the amount of mental energy it is taking is quite a bit. Shit. That was cool. That was good. Cool. Okay, so 4 questions down. 4 questions down for the day. This one, this one, this one, and this one. This one. No, yes, we began with round dancing. That is nice. Wait, code forces is not up. Code forces is up. Let's guess the tags. And I think tags are going to be sorting. We did do sorting in our solution. So tags are going to be sorting and 2 pointers, I guess. Let's see. Greedy, constructive, or nothing we said. Okay. Yes, it is constructive algorithm. There is, by the way, actually a pretty good article which I haven't read on constructive algorithms here. Algorithms, constructive algorithms, this by Real Narrow. Constructive algorithms. Should I have read this article? Yeah, yeah, this was fine. But an article which is actually good is this one, How to Read Problem Statements by Umnik. And Mr. Mike Mirzanov also has articles. Okay, let's read the tutorial for this. That would be nice. Question number D, and the name is Shocking Arrangements. Shocking Arrangements, question number D. Hint 1, express maximum this in a simpler way. Yes, we can express this in a simpler way. How? Prefix sum. Prefix sum of array A. Okay. And then hint 2, build the answer starting from an empty array if you add numbers to this response. So the prefix is in the half interval. of this and this. The resulting array will fit the condition. How to do it? Remember, the sum of the array is 0. Yeah, the sum of the array is 0, and that is like pretty nice. Pretty nice. Cool. If the array consists entirely of zeros, then it is impossible. Otherwise, we will put all zeros at the beginning. Now our array is without zeros. We add the elements into the array in order. If now the sum of the added elements is less than 0, we take any of the remaining positive numbers. We add elements into the array in order. If now the sum of the added elements is less than equal to 0, initially it is equal to 0. So yes, we will take any of the remaining positive numbers as the next element, since the sum of all the numbers is 0. Okay, a positive number is guaranteed to be found if there are still numbers left. If now the sum is greater than 0, we now take any of the remaining negative numbers as the next element again. Since the total sum of the numbers is 0, a negative number is bound to be found. Why it works? The maximum number of the form this is the prefix a minus prefix min b, including 0. According to the structure of the algorithm, it is clear that the resulting array, this thing is not deviating too much and smaller than prefix min. In total, the condition will be met. And I think the algorithm, this one that we have written, this does not take advantage of the fact that the sum of all the numbers is equal to 0. This is more general and this is more specific, fine-tuned for this solution. That is fine. Yeah, let's move on to the next question. The fourth question for the day, and it is going to be pretty cool. Shocking arrangements. Okay, this thing is not refreshing, not verified with code forces. Let's go to the next question. This one, triangle coloring, 3 seconds. We can use half GB of data. And this was educational round question. Shit. D question. Shit, are we already at D in division 2? That is nice. Question D. Bro, what are you studying? We are doing competitive programming. We are trying to be one of the best in competitive programming. And for that, we are following this sheet, CP31. This has questions rated in difficulty, smallest at a rating 800. And we have gone through, we started at 800 rated questions. Now we are at 1600. That is like double difficult than from where we started. And we are kind of booming through these questions. We have done today 3 questions in a row. Round dance hits different, shocking arrangement. And now we are on to the fourth question. And that is pretty nice. Oh shit. Yes, I am in a college. I am in college, third year. But I don't go to college. College is bad. Do not go to college. Okay, let's do this. The fourth question for the day. 1600 rating. You are given an undirected graph consisting of n vertices and n edges where n is divisible by 6. Each edge has a weight which is a positive integer greater than 0 integer. The graph has the following structure. It is split into n by 3 triplets of vertices. It is split into n by 3 triplets of vertices. Okay, there are ny3 triplets. The first triplet consists of vertices 1 to 3. This is okay. Every pair of vertices from triplet is connected by an edge. Every pair, so 4 to 5, 5 to 6, 4 to 6. Okay, there are no edges between vertices from different triplets. You have to paint the vertices of this graph into two colors, red and blue. Each vertex should have exactly one. We have to color the vertices. Okay, each vertex singular should have exactly one color. There should be exactly n by 2 red and n by 2 blue vertices. The coloring is called valid if it meets this constraint. The weight of the coloring is the sum of the weights of the edges. Okay, that is why n is divisible by 6. Okay, and so n is even and also divisible by 3. The weight of the coloring is the sum of the weights of the edges. The weight of the coloring is the sum of the vertices of edges connecting to different colors. Okay. Okay. So we in each triplet we can choose which edge we want. Let W be the maximum possible weight of a valid coloring. Calculate the number of valid colorings with weight W and print modulo this. That is shit. Okay. W be the maximum possible weight of a valid coloring. Calculate the okay, this is dynamic programming. Yeah, this is dynamic program. No. Yes. Yes, this is dynamic programming. Yeah. Let W be the maximum possible weight and calculate the number of valid weights with this and print it modulo this. Okay. 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 N can be very big. Okay. And the second line contains n integers and each individual weight is not bigger than this. And what is the biggest weight? W. What is capital W? Calculate the number of valid colorings with weight W. W be the maximum possible weight of any valid coloring. Okay, so how many ways can we achieve this weight W? Calculate the number of valid colorings with weight W. 6 plus 6. Here answer is 6. Yeah, wait, 2. Okay, this 2 into 1. Okay, and here actual answer is 36. Let's see. I have some algorithm in my head. Here these are divided like this. This is one triplet, this is another, and this is another. What is the maximum? The maximum sum W is going to be from any triplet. We can choose any number. So let's say we pick the maximum numbers from all of them. 4 plus 2 6 plus 2 14 plus 3 17 is the maximum. How many ways can we achieve this sum? 17. So from the first triplet, if we have three choices, let's choose one. When we choose one, we want a sum of 16 from these, right? Let's choose 7 from this, and we want a sum of 9 from this, and it is never possible. So 0. Let's choose the second number, 8 from here, and since we wanted 6, we want a sum of 8. 8 is also not possible, so it is 0 for this. If you go with 5, again 0. So for 1, 0. Then for 3, let's choose 3. If you go with 3, we want total sum to be 14 in this range. And let's go with 7. When we go with 7, we want sum of 7 from this, but we cannot have 7, so 0. Then we go with 8, and with 8 we want a sum of 6. And there are multiple ways to get a sum of 6. You must choose this 4, and we have 3 options here. So there are 3 ways. So answer is 3, plus we will add some other numbers. Now if we go with 8, sorry, with 5, if we go with 5, if we go with 5, then we want a sum of 9, and that is not possible, so 0. And so for this 3, there are 3 ways, and for if we go with this 3, there are 3 ways. So answer should be 6, but answer is 36. Maximum possible weight is 31. How is it 31? 4 plus 8 plus 2, 10, 14, 3. How is the okay, I don't get. The weight of a coloring is the sum of weights of edges connecting two different set. Okay, we can have like multiple colors. Shit. If we have, let's say, we will have 6 vertices at least, right? And let's say we have 2 colors, red and blue, red pill, blue pill. And this is 1 inch. Okay, edges do not have colors. Yes, edges do not have colors. It is the vertices which have colors. Yes, it is the vertices which have colors. Let's color this one. We want the total to be half, half. Yeah, sure. We can color all of these red and all of these blue, and we won't get any sum out of this. But if we were to change these colors and let's say remove this and this, and let's turn this one blue and this one red. Now we get the sum of this. Okay, so yes, okay, shit. So from each triplet, we can get 2 numbers to be added to the final sum. And we can think of it as if we are taking the sum of everything and we are only reducing the smallest number. So the total sum here would be 1 plus 3 plus 3, that is 7, 7 plus 7, 14, plus 8, 22, plus 5, 27, plus 6, 33, plus 8, 41. 41 minus 1, 40, minus 5, 35, minus 2, 32, minus 2, 31. That is actually the greatest sum that we can have. Yes, that is correct. Okay. So let's see which number we are removing and we can move forward with that. Okay, since the total sum was equal to 41 and our maximum sum is going to be equal to 31. So our target sum is 10 when we are using just no one edge from each of uh, each of the triplet. So we have something like this, right? And let's mark the triplets. And yes, that is like this kind of getting crazy. Okay. Anyways, these three are one triplet, one triplet, one triplet, and one triplet. And our target sum is 10. Let's say we choose this one, and we are now, since we have chosen this one, we want a sum of 9 from these remaining triplets. Let's say from this one we choose 7. If we choose 7, we want a sum of 2 from these remaining, and we cannot have a sum of 2. So answer for 7 is 0. And yeah, so then we go with 8. When we go with 8, we want a sum of 1 from this, and that is also not possible. So 0 again. And when we go with 5, we want a sum of 9 minus 5, 4, and we can have a sum of 4, and there are multiple ways. We have 3 2's we can choose from here, and we have 2 2's we can choose from here. So in total, we have 10 ways for 5. So in total, when we go with 9, there are 10 things, 10 ways to choose numbers. Now, when we go with 3, answer should be 0. When we go with 3, answer should be 0. Shit. Okay, how many choices, however many choices there are, our answer will be 2. Uh, 2 into 10, because we can always just switch all of the all of the colors, and we will get symmetric, new symmetric configuration, which in which all the colors are just switched from the original one. Okay, yes. But actual answer is 36. So we should have something like 18 before this. Let's just consider this much. Yeah, let's just consider this much. We have one node, we have some nodes, right? We have a node here, we have a node here, and a node here, and we have one other triplet. These are connected like this and like this. Cool. In one triplet, all the edges have the weight 2, and another 2, 2, and 4. Now we need to color them in red and in blue. So what are the possible ways? Since we want to get weight of this edge and the weight of any of this edge, that is nice. So this and this node should be in different colors. That is a given. And every other color can be in any other way. Does not matter. So, okay. Yes, that does not matter. Now, and the number of blue edges, the number of blue vertices, and the number of red vertices have to be equal to each other. And in total, we will be using 3 red and 3 blue vertices, and among them, we have already used up 2. So we have 2 blue and 2 red vertices remaining, and these 2 can take up 4 positions. So 2 into 4, 8 possibilities, and remaining will be taken by 2, the blue ones. So that is already counted in this. And also we can switch these initial colorings, and you can say we color this one in blue and this one in red. And now, yeah, so we have 8 more possibilities. So answer is 16 for these two vertices. But in our original question, we have, yeah, in this when we have like two triangles, but here we have multiple triangles. Here all the values, when all the values are different, we will count the number of edges which are fixed, like we do want this. And here, yeah, does not matter. We can go any way we want. And here we do want this, but sure, yes, we always want the maximum one. Okay, okay, from each edge we always want the maximum one. Okay, so there are only three possibilities a triangle can have. Every triplet can have three possibilities when all the nodes, all the edges, x, y, and z. If we have three possibilities, right? Possibility number one, when x equals y equals z. That is possibility number one. Possibility number two is x is that two are different and z is not equal to like any one of these. And possibility number three is x not equal to y, which is not equal to z, and yeah, they are not equal to each other. But here, so yes, here we can choose anything, does not matter. Here, if z, the one that is different, is the biggest, so this is fixed. Two colors are fixed, and we can keep a counter of such edges, and let's say we will call it C, very original name. But if these two are the biggest, z is the smallest, then we do not want z, and in that case also z is fixed. Yes, in that case also z is fixed, so we increase the counter still. And when none of them is the biggest, none of them are equal, then two of them are going to be same. We want to roughly how many questions you solve per day. Like I'm trying to increase the number of questions I solve per day. I have not been solving enough questions, and to be more specific, uh, 3 to 4 questions. Yeah, I do solve here on the stream. I have yet solved 3 questions today, and yeah, I'll be solving more after the stream also. There is like this one, and also questions from yesterday's contest, question number D. That is also something. But yeah, now I'm trying to solve at least about 10 questions per day because I'm not solving enough. We do want to get to 2000, right? We are not kidding about that. I'm already at in this month's rating, but 2000 is a lot. we will take this count. Okay, so we will count the number of triplets which are like this and the triplets which are like this. Okay, so in our original, this one here, this one, let's say same, where all the values are same, we have 1, and where all the values are different, we have 1, 2, 3. 3 triplets like this, and the answer has to be something related to this. I think actual answer is 36. I think answer has to come from a closed formula from something like this. That would be the answer. We just have to figure out the formula for this. Okay, let's create the triplets and manually find out everything. This, we have 4 triplets in our example. And yeah, and this is how the triplets are. This is one triplet, this is another, this is another, and this is another. We have 4 triplets. This, this, and this, all of this. Now let's give them values 1, 3, 3, 7, 8, 5, 2, 2, 2, and 2, 4, 2. From this, we always want 3 and 3. Let's say we have 2 colors, red and blue, in which we can color these. Right. Since we always want 3 and 3, and we do not want 1, so we will color the edges of 1 in the same color. Let's say we begin with blue, right? And this one would be red in that case. Here, we always want 4. That is the only case. So we want edges of 4 to have a specific color, to have different colors, and this single color can be anything we want. Here we do not want 5, we can put 5 to give 5 some color, and red. How many red we have used? In total we need to use 6 red and 6 blue colors. We have used 1, 2, 3 red and 1, 2, 3, 4, 6 blue. Okay, so in the next case, everything can not be red because we won't be getting any value. So shit, that is not good. So we have to make some switch ups. 2 edges will always have some colors, and edges will always have some colors. Let's just talk in pairs. How many ways to arrange colors in this? How many ways to arrange colors in this and multiply them? Maybe that. Okay. So if we have chosen this, right? So here currently red. We do not want 5, so we color both of these red. That is one possibility. And if we switch up these red, yeah, in total we have just 2 possibilities here. How many possibilities do we have here? Here we can color all of these in any way we want. And here, let's say we go with red and blue. Red and blue initially. Then we have two red colors, two blue colors remaining, which can go into 4 different positions. Two colors can go into 4 different positions. So one color goes into has 4 possibilities, and the second color has 3 possibilities, in total 12 possibilities. And if we switch up these original colors, that is 12 more possibilities. So 24 possibilities in total. Multiply that by 2 possibilities from here, 48 that is wrong, because the correct answer is 36. The real answer is 36, not 48. And how long has it been? It has been 3 hours and 16 minutes. That is quite a bit. Okay, yeah, I can come back to this question at some point later. Yeah, but we have done good. We have done good today. We did 3 questions, 1600 rating. That is good. That is good. That is good. We did the first question in 43 minutes, the second question in 40 minutes, and the third question was good enough in 30 minutes. That is good. And now we are leaving the fourth question. That is fine. Yeah. I guess, yeah, I can just take a rest and get back to this after some time. And for today, yes, we have done 3 questions. That is nice. 6-0 rating. What do you mean? Hamad Sar. 6-0. What is 6-0? These are 1600. Oh, yeah. 1600. These are 1600 related questions. Yep. And we are doing these. Yeah. We did 3. That is like good enough. I guess we just have to, yeah, grind more and solve more questions of the stream also. Oh, 600. My bad. Yeah, that would be it for today. 3 questions. That is nice. That is nice. That is nice. Okay. Yeah. So for today, that would be it for the stream. Yep. For today, that would be it for the stream. We did 3 questions, 1600 rating, and that is nice. Thank you for being here. And you are asking for tips. Now, you have to find your own reason why you want to get better at this and why you want to be consistent. And if you do not have a good enough reason, a strong enough reason, then you would always stop. So find a reason why you want to be good at competitive programming or anything. And if you are unable to find a reason, then maybe you don't actually want to be good at competitive programming and you are just hoping that it would be good to be good. Right? I think that makes sense. It is like what Nietzsche says. If you have a strong enough why, yeah, yeah, this thing, motivation. He who has a strong enough why for which to live can bear almost anyhow. That is it. Nietzsche, Friedrich Nietzsche. And yeah, that would be it for today. And thank you for being here. Bye.